Negative numbers are any number.
Can you imagine life without modern mathematics? No trips to the moon, no 8-figure salaries, no fortnight.
Oh no!
Then you owe a lot to nothing and the man who discovered it. Brahmagupta, an Indian mathematician and visionary, 1500 years ago laid the very foundation of almost every scientific development through his most important discovery of nothing, shunya, zero. He gave zero its own identity and then split it into two equal but opposite components, giving birth to negative numbers.
Oh yeah!
He then invented the rules for calculation with zero. Went a little wrong with division though. His numeric ideas of zero to negative numbers.
Oh yeah!
He then invented the rules for calculation with zero. Went a little wrong with division though. His numeric ideas of zero cradled computations of currency, astronomy, scales, coordinates, thermometers, and the revolutionary computer language of zeros and ones.
I'm so cool. No, I'm so cool.
Though known for the advent of zero, Brahmagupta has many firsts to his name. Explanation of eclipses, concepts of trigonometry, geometry, and many other important formulae, estimation of the value of pi, and even gravitation. That's right, he was the first one to identify gravity 1,000 years before Newton. He wrote 4 important books containing all his work, one of them being Brahmasphata Siddhanta. Yeah, try saying that 5 times non-stop. His ideas travelled all over and in almost every field. Then why did he vanish into oblivion? Well, though his theories were bedrock for many inventions, unlike his work, these inventions were backed with more facts and proofs later. Thus, the credit shifted to the New Age scientists. And our dear Brahmagupta got a mention for nothing. Well, ask him that now. He wouldn't mind.
Negative numbers are any number less than zero. Imagining something less than zero can be difficult. Suppose you have a bowl of oranges, and someone takes them away until you have zero left. When there's nothing, it's hard to imagine being able to take away more. However, there are instances in real life where we use numbers less than zero. For example, did you know the average temperatures at the top of Mount Everest range from negative 19 degrees Celsius to negative 36 degrees Celsius? Wow, that's cold! Negative numbers also appear a lot in finances to show debt. Suppose you have $50 in your bank account, but then you accidentally spend $60. Your account's balance is now negative 10. This means you owe the bank $10. To understand negative numbers even more, let's look at a number line. For every positive number, there is a negative number. Negative numbers can also be thought of as the opposite of a positive number. So, the opposite of 5 is negative 5. You might also notice that as we go further down the number line, the negative numbers appear to get larger. However, the numbers are really getting smaller. For example, negative 10 is smaller than negative 5. This can be confusing, but think about it in terms of temperature. Suppose on a winter's day it's negative 25 degrees Celsius in Barrow, Alaska, and negative 35 degrees Celsius in Stanley, Idaho. Stanley would be colder than Barrow because negative 35 is lower than negative 25. Now you know the basics of negative numbers.
Can you imagine a world without the internet?
Without one man, the internet may not have existed.
Physics genius, entrepreneur, and the man who bent light, Narinder Singh Kapani. Born in 1926 in Punjab, India, he is known as the father of fibre optics.
What is fibre optics? When you send an email from your computer to your friend, the information travels down cables. These cables are known as fibre optic cables.
These cables are made of thin glass wires or fibres, about as thin as a single human hair. The information is sent as light signals down these glass fibres.
When he was a schoolboy, Gopani disagreed with his teachers, who said that light cannot travel around corners.
He tried lining up prisms to bend the light, but it did not work.
As a PhD student, he directed a beam of light through a bundle of bent glass fibers instead of prisms, losing hardly any signal. These astounding results were published in 1954.
He was the first person to show that light could be sent down bent glass fibers, and he invented the first fibre optic cable in 1952.
In 1977, the first telephone connection by optical fibers was achieved. Due to Kabani's work, we have networks of these cables that have made the internet and instant high-speed communication possible.
His work has also transformed medicine and engineering, as we now use medical imaging equipment that is fitted with optical fibers in order to explore the inside of the human body, and sensors to measure temperature, pressure, and voltage.
Despite all of Kabani's groundbreaking work in the field, the 2009 Nobel Prize in Physics was awarded to Charles Quen Cao.
Nevertheless, Narinder Singh Kabani's story is extremely inspirational. He has over 120 patents and 100 scientific papers to his name. He's been an esteemed professor at several US universities and has founded 3 companies and the Sikh Foundation.
It is clear that the time has come to shed some more light on this figure who was made invisible by history.